In a previous lesson, we went over how to solve a quadratic by factoring, and today we're going to talk about other methods that you can use for solving quadratics. So before we get started, I just want to remind you it's a video. You can pause, rewind if you need to, rewatch an example if you want as well. So this first section is going to go with your workbook 2.1, and that's solving quadratics by taking square roots. So example 1 says x squared equals 16, and when we're solving, our goal is to isolate x. That means get x by itself, basically, because we want to figure out what x value makes the equation true. So right now, I have this x that's being raised to the second power. So in order to undo the second power, I have to use its inverse operation, which is a square root. So a square root would undo like a squared exponent. And then whatever I do to the left side of the equation, I have to also do to the right side of the equation. So square root cancels out that to the exponent, and then I'm left with x equals, the square root of 16 is 4, but when we're solving, we have to figure out, okay, is 4 the only possible answer? Because I know like the square root of 16 is 4, because if I were to take 4 and square it, I would get 16. But if I were also to take negative 4 and square it, I would still get positive 16. So there's technically two possible answers. It could be positive 4 or negative 4. You can write it separately if you want, like x equals 4, x equals negative 4, or just like this if you want to, and then just know you might have to change it depending on what your workbooks are asking for. So example 2, 49x squared minus 14 equals negative 6. So same goal, just some more steps that go along with it. So our goal is to get x by itself, and there's a few things being done to x. So I have the 49 that's being multiplied by it, the x is being squared, I have the 14 that's being subtracted from it. All that's being done to the x, I want to figure out what order is going to make it easier for me to get x by itself. So usually it's easiest to undo addition or subtraction first if you can, before we worry about undoing like the multiplication or division, that 49. And the reason is because if I say I want to cancel out that 49, I would have to do the opposite of multiplication, which is division, but I have to divide everything in the equation by 49, which includes the 14. So I might as well just kind of cancel out that 14 first and then move forward. So if I want to undo the minus 14, I have to add 14 to it, because the opposite of subtracting 14 is adding 14. Whatever I do to the left side of the equation, I have to do to the right side of the equation as well. So I'm going to bring down this 49x squared. The negative 14 plus 14 cancels out. Bring down my equal sign, and then the negative 6 plus 14 is 8. And then now still trying to get x by itself. You can technically square root right here, but I would recommend getting rid of the coefficient of x, which coefficient is like the number that's being multiplied by x out in front of it. So I'm just going to go ahead and divide both sides by the coefficient 49. So 49 divided by 49, that's just 1. So I'd be left with just a 1x squared, but we don't need to write the 1, so we just have x squared. And then 8 divided by 49, that's going to give me like a funky decimal. And in general, I'd rather you leave it in fraction form so that we can take the square root of it a little bit easier and without a calculator, hopefully. So if I have 8 over 49, I'm just going to copy that down. And then now the only operation being done to the x is it's being squared, so I'm ready to go ahead and cancel that out. So I'm going to square root both sides to get rid of that like 2 power. So it clears away the 2. I'm going to just have x. And then when you take the square root of a fraction, and I know sometimes it looks like two like ugly, confusing things combined into one, but you just need to treat it as like two separate problems. So because we're taking the square root, I'm going to go ahead and put my plus or minus in front right away, because anytime we take the square root when we're solving, we're going to have that. And then I'm going to separate the radical. So I'm going to put the square root of 8 in the numerator, and then the square root of 49 in the denominator. And then now I'm going to simplify from there. So I'm going to bump this up here just so I have a little bit more space. So I have x equals my plus or minus out in front, and then I'm going to have my fraction bar. I'm going to take the square root of 49 first because I know that that's 7. And then for the square root of 8, well, 8's like not really a perfect square, but it does have a perfect square factor. So perfect squares are like numbers that you get from squaring another number. So like 4, 9, 16, 25, and so on. Those are all perfect squares. And 4 is a factor of 8. That means that I can simplify it. So one of the ways I like to simplify radicals is using like a factor tree. And there's a couple of different ways to simplify it. In your workbook in 2.1, there's a review and they do it a different way. So I'm going to choose an alternative way here so you can decide which one you like between the two. So I'm going to set up my factor tree. So I'm going to take my number 8 that's inside the radical that I'm trying to simplify, and I'm going to break it down into its prime factors. So 8 I know is 2 times 4. 2 is prime, so I wouldn't go any further from there. And then 4 is 2 times 2. So when you're simplifying a radical with a factor tree, you're looking for pairs of the same numbers. So I have a pair of 2's, and that means a 2 would come outside of the radical. I still have my radical because I have some numbers left over that are not a part of a pair. I have that 2 that's left over. So that 2 that's left over stays inside. And you only look at the very like bottom numbers of your factor tree. So I'm not looking at the 4 and the 8. I'm only looking at the prime number at the bottom, like kind of like the leaves of the tree, I guess. So our final answer would be x equals positive or negative 2 root 2 over 7. Okay, example 3, we have something that is being squared along with the x. So x plus 12 squared equals 64. I want to isolate the x, but I can't like subtract out this 12 because it's in parentheses with the squared. So I can't get rid of that yet. It's kind of like it's in jail cells. So I just want to make sure that there's nothing outside of the parentheses that I can clear out. So like I have nothing being multiplied in front. I have nothing being like added or subtracted after the parentheses that's, not inside of it. So the parentheses is isolated. So now I'm going to go ahead and try to cancel out that 2. So I know to do that, I have to square root both sides. And then when I do that, the square root and the 2 power just cancel each other out. So I'm just left with what I had inside, which is x plus 12. And then when I take the square root of 64, it's 8. But because we're solving, we have to include the positive and the negative 8. And then from here, anytime this happens, I'm going to compare this back up to example 1. So when we took the square root of 16 and got plus or minus 4, we were done there because this x was isolated. In this case, the x is not isolated. We would need to go ahead and cancel it out. So I'm going to go ahead and minus 12 from both sides to get x isolated. So then I have x equals, I'm going to put the minus 12 first. You can decide which one you like to put first on your own. So my negative 12 and then plus or minus 8. But this, like, we can find this answer. It's going to be 2 different integers. To do it, it's a little bit easier if we just go ahead and set up 2 separate equations. One that has the plus and then one that has the minus. So one is going to be x equals negative 12 plus 8. And then the second equation would be x equals negative 12 minus 8. And then now we've just solved them both separately. So x equals negative 12 plus 8 is negative 4. And then x equals negative 12 minus 8 is negative 20. So our 2 solutions are x equals negative 4 and x equals negative 20. And then example 4, so last one for solving by square roots is x plus 4 squared plus 8 equals 5. So same idea as example 3, where we want to try to make sure what is in parentheses is isolated, or like at least the parentheses are by themselves before we go ahead and cancel them out. So right now I have this 8 that is added after the parentheses. So I want to clear that out. I'm going to go ahead and subtract 8 from both sides to cancel the plus 8. So I'll bring down my x plus 4 squared, and then 8 minus 8, that cancels out, and then I have 5 minus 8, which is negative 3. And then from there, I'm ready to go ahead and kind of cancel out the 2 to the power of the squared. So I'm going to square root both sides. And then the radical cancels out the power, so I'm left with x plus 4 equals the square root of negative 3. And the square root of negative 3 is not a real number, so we can actually stop here and say no real solution. And if you've looked ahead in the workbooks at all, you may have seen like the complex number term. That's something that we're going to get to next. So like throughout Algebra 2, we won't always stop at this point when we get a negative inside the radical. At some point, or I guess within the next lesson, we'll have a better way of representing that answer, a more complete way. But for today's workbook, we can stop and say no real solution because it is not a real number. We can't get like two numbers, or I guess one number that when we square it, it's a negative. So this next section is solving by completing the square. There's two examples on here. You can see on the first one that I have like each written step. I would use those as like a guide as you're going through your own problems. So example 1 is x squared plus 8x minus 30 equals 0. And if we start with step 1, it says divide both sides of the equation by the leading coefficient. But our leading coefficient is 1. So if I divide the entire equation by 1, it stays the same. So I don't really need to do that step. So then the step 2 says isolate the terms involving x on one side of the equal sign. So my terms that involve x are x squared and 8x. So I need to isolate them. That means I need to get them by themselves on one side of the equal sign. So I need to find a way to eliminate this minus 30. So to cancel out minus 30, I would add 30 to both sides. And then I'm going to bring down my x squared plus 8x, and then equals positive 30 now because these canceled out. And then now we can move on to step 3. So step 3 says find b over 2 squared and add it to both sides of the equation. This goes back to like a is the coefficient of x squared, b is the coefficient of x, and then in this case I don't have a c, which when you're completing the square you don't want there to be a c, you just want a and b. So b is 8. So I'm going to take 8, put it over 2, and square it. I just took my b and I substituted it into that little formula that was listed under step 3. So we'll simplify. 8 divided by 2 is 4, and then 4 squared is 16. So it says that we need to add that number to both sides of the equation. So that 16 is going to get added right here and right here. So after the 8x and after the 30. So it'll be x squared plus 8x, and then plus 16 equals 30 plus 16. And then now what we did on the left side is we created what's called a perfect square trinomial. So you'll see on step 4, it says factor the perfect square trinomial. You can technically factor this like in the methods that we learned in the last lesson, but there's kind of a shortcut. So perfect square trinomials always factor into a binomial squared. So that means that there's two terms inside the parentheses and then it's squared. So the pattern is that you take the first term and you take the square root of that, and that goes first inside here. So there's an x inside there first. And then you take the symbol from the middle term. So that's a plus 8x, so we have a plus here. And then if it was minus 8x, we would put a minus. And then we take the square root of the third term. So the square root of 16 is 4. And then we're done, and we just got to add on the other side. So equals 30 plus 16 is 46. And now we have an equation that's like solvable by square roots, like all the problems up above were. So step 5 says take the square root of both sides and solve for x. So I'm going to go ahead and zoom in now that we're kind of done with each step. So take the square root of both sides. That cancels out the power, and I'm left with x plus 4 equals, I'm going to put a plus or minus in front just so I don't forget it later on, plus or minus the square root of 46. 46 is not a perfect square, but we just want to make sure that it doesn't have any perfect square factors. So I'm just going to make a quick little factor tree. I feel like that's the easiest way to do it. So 46, it's even, so I know I can divide it by 2. So it'd be 2 times 23. And then 23 is prime, so I can't actually go any further, and I don't have any pairs in my factor tree, so that just means that we actually can't simplify the square root of 46. So we just have to work on isolating the x. So I'm going to subtract 4 over. And then when we write our answers, when they have like a constant or like a regular type of number and a radical, we usually put the integer first. So I'm going to put this minus 4 first after the equal sign. So it'll be minus 4, and then next I'll put this plus or minus the square root of 46. So x equals negative 4 plus or minus the square root of 46. Okay, and then I'm just going to go through really quickly and label each step number just so you can kind of go back and reflect on that. So step 1 we did not have to do just because the coefficient, the leading coefficient was 1, and if I divide an equation by 1, it's not going to change. But step 2 we did right here. Isolate the terms involving x on one side. Step 3 we did over here, but then we also had to add it right there because it said to find that number and then add to both sides of the equation. Step 4 said to factor the perfect square trinomial, and then remember you can do that using kind of like a pattern. And then step 5 was to take the square root of both sides and solve for x. That's what we did down here. Step 4 and step 5 are kind of on the same line, so they're a little bit compressed. Okay, so example 2, we're just going to go through the same list of steps. So step 1, divide both sides of the equation by the leading coefficient. So in this case, I do have a leading coefficient other than 2, so I'll want to divide by it. So, sorry, the leading coefficient is negative 2, so I'm going to divide everything by negative 2. And I think I accidentally misspoke earlier. I have a leading coefficient other than 1, so I will actually need to do that step. So I'm going to divide everything by negative 2. So negative 2x squared divided by negative 2, that turns into just regular x squared. And then plus, actually I'm going to take that away, we have 5x divided by negative 2, so I have a positive 5 divided by a negative 2, so it's going to turn it into a minus 5 over 2, and we're just going to leave it as a fraction. And then plus or positive 6 divided by negative 2, that turns into a minus 3 equals 0. And before we get started, this is going to be kind of like an extreme form of this problem where it's a little bit more difficult than you would typically see, but it's mostly to help us see what makes this problem easier versus more difficult, because there's definitely certain characteristics of the problem that you should look for when you're choosing this method to solve. Okay, so step 2 is to isolate the terms involving x on one side of equal sign. So the terms that involve x are these two, so I want to get those two by itself. So in order to do that, I'm going to have to add this 3 over. So then I have x squared minus 5 halves x, and then equals positive 3. And then from there, I can move on to step 3. So it says find b over 2 squared, which b is this negative 5 halves. So I have to find that number over 2 and square it. So that's kind of ugly. I'm going to make myself a note of what b is up here. This is where it gets a little funky. So b is negative 5 halves, so I'm going to do negative 5 halves, and then I have to put that over 2 still, and then I have to square it. And I have to figure out what that number is, and then I have to add it to both sides of the equation. So usually instead of like dividing fractions, we multiply by the reciprocal. So I'm going to take this is like negative 5 halves divided by 2. But instead of dividing by 2, I'm going to multiply by the reciprocal of 2. So I'm going to multiply it by a half. And then I still have to square it after, so I'm going to put it in parentheses and square it. And then if we're multiplying fractions, we can just multiply straight across. So negative 5 times 1 is negative 5. And then 2 times 2 is 4. And then in parentheses squared, and when I square fractions, I just need to square the numerator and the denominator, the top and the bottom. So negative 5 squared is negative 5 times negative 5, which is positive 25. And then 4 squared is 4 times 4, so 16. So this 16, or 25 sixteenths, is what I have to add to both sides of the equation. So it's going to get added right here and right here after the 3. So I'm just going to go ahead and bump this over right now. I have x squared and then minus 5 halves x, and then I have to add that fraction in, so 25 over 16 equals 3 plus 25 over 16. And then I'm gonna actually just kind of flip my order to give myself more like room on the side of the 3, because that'll come in handy in a second. So I'm gonna do 25 over 16 plus 3. If you want, you could just leave a little space after the 3 if you don't want to switch the order. So that 25 sixteenths, that came from the b over 2 squared, and we had to add it to both sides of the equation. So we're done with step 3. Now we're on to step 4. It says to factor the perfect square trinomial. So we know it's going to go into a binomial squared. And then I'm going to zoom in for this part. So we would have to take the square root of the first term. So the square root of x squared is x. That one's easy enough. And then we take the sign from the middle term, so minus. And then we have to take the square root of the third term, which the square root of a fraction is just the square root of the top over the square root of the bottom. So the square root of 25 is 5, and the square root of 16 is 4. And then that's going to be equal to 25 over 16 plus 3 over here. But we kind of want to add those together, so we need to get a common denominator. So to get a common denominator, I have to multiply numerator and denominator by the same number. So my denominator is going to have to be 16 so that those can match up. So I'm going to take the 3 and I'm going to multiply it by 16 over 16. Because if I multiply something by 16 over 16, that's just like multiplying by 1, so I'm not changing the value, but it is going to give me that common denominator that I need. So this is going to be 25 sixteenths, and then plus 3 times 16 is, I'm blanking, I think it's 48, but I'll double check. Yeah, 48. So plus 48 over 16. And then now that they have the common denominator, we can add them, because in order to add or subtract fractions, they must have the same denominator. So I'm not going to square root yet, so I'm not going to move down to step 5. I'm just going to copy this left side down so I can add my fractions together before I square root. So when you add fractions, you just add the numerators. The denominator does not change. So we would just do 25 plus 48, and that's 73 over 16, and then now I'm ready for step 5, which says to take the square root of both sides, and then we can solve from there. So I would need to square root the left side, and then I also need to square root the right side. Square root in the left side just cancels out the power. So if I cancel out the power, I have just what was left inside the parentheses, which is x minus 5/4. And then I'm left with the square root of 73 over 16, so I'm going to put my plus or minus out in front. And then I just need to take the square root of the numerator and the denominator, so the square root of 73 cannot be simplified. So that's just going to stay inside the radical. And then over the square root of 16, which is 4, without the radical. And then now I need to get x by itself. So I still just have that like minus 5/4. So to cancel that out, I'm going to go ahead and add the 5/4 to both sides. And it's kind of cool. I don't know, maybe not the same version of cool as everything else. Oops, that's supposed to be a 4. That these have the same denominator. So like the 5/4 and the 70 or root 73 over 4. They have the same denominator, so we can actually write them all as like one just big fraction so that it's a little bit like more simple. So I'm going to write my fraction bar. I'm going to put the number without the radical first. So it's a positive 5 plus or minus root 73. So 5 plus or minus root 73. And then because they have the same denominator, I can just put that whole thing over 4. If for some reason they did not have the same denominator, you could just write it as two separate fractions. You wouldn't have to simplify it further necessarily. And then I'm going to move this over here just so it doesn't get cut off. Okay, so looking back, there's a couple things that were like different between this problem and the last problem. One doesn't impact it a whole lot. One did make this problem substantially harder. So the thing that I guess initially was different about these two problems is one had a lead coefficient of 1 and one had a lead coefficient of -2. That's not really what caused like this whole mess though. The thing that caused this mess was having b be a fraction, because then we had like a fraction over a fraction, and then we were dealing with fractions like all the way through, and I don't mind them, but I know they're not everybody's favorite, so it's best to avoid this method if b is a fraction or if it's odd. So leave a note at the top that it's best to use this method when b is even, specifically. So you don't really want it to be a fraction, you don't really want it to be odd. And we don't have an odd example on here, but the reason we don't want it to be odd is because if I put an odd number into this formula under step 3, it's an odd number over 2, so that's going to give me a fraction, and we would like to avoid that. So this one is best when b is even. If there's ever a situation where it's not, then the next method is usually best, the quadratic formula. Oops, I don't know what happened. It's all my radical over here. Okay, so moving on to the quadratic formula. So we learned it, we may love it, we may hate it, I don't know. But the quadratic formula is x equals -b plus or minus the square root of b squared minus 4ac all over 2a. And then we do need to remember what standard form of a quadratic was. I'm going to go ahead and just add like an equal 0 after this because it is going to be like an equation. So we want everything on the left side of the equal sign equal to 0, and we want it in order of highest exponent down to the constant. So the ax squared first, the bx second, and then the constant c next, and then that's equal to 0. Once it's in standard form, we can just pull out our a, b, and c and put them in the formula and simplify from there. Okay, so going through this is 3x squared plus 5x minus 6 equals 0. So a is 3, b is 5, c is -6. So I think I'm going to color code it actually. So a is 3, so it'll go right here and right here. And then b is 5, so that'll go right here and right here. And then c is -6. So keep in mind you have to include the negative. It gets a little tricky with that, so it goes right there. Okay, so I'm just going to keep going from this line. I'm going to draw that big fraction bar so I have something kind of to fill in. So it starts with -b, which b is 5, so it'll be -5, and then plus or minus the square root of b squared, so 5 squared, and then minus 4 times a, so times 3, which was a, and then times c, so times -6, and then all over 2a, so 2 times 3. And then I'm going to keep going, just kind of start to simplify what's inside my radical for the most part. So -5 first, and then plus or minus the square root of, so 5 squared, that's 25. And on this next part specifically is like where most people kind of make their mistakes. So the way I like to do it is I like to think of this negative as belonging to the 4. So like not a minus, but a -4. So do -4 times 3, which is -12. And then -12 times -6, which is positive 72. So it'll be plus 72. So one more time, I like to just include the negative like with the 4. So -4 times 3 is -12 times -6. A negative times a negative turns it into positive 72. And then over 2 times 3, so over 6. And then I can add the numbers inside the radical next. So -5 and then plus or minus the square root of 25 plus 72 is 97. And then over 6, and then we just want to check to see like if 97 can be simplified. I don't think it can be, but I'm just going to make a factor tree just to double check because it's good practice just to always double check. So 93, I will have to guess and check the factors if you know them. Nice. I don't know them, but 97, I'm going to try dividing by 3 because it's not even. So that gave me a decimal, so that's no good. I can try 97 maybe divided by 7. That did not work. I'm going to try 97 divided by like 13. Not getting very far. 97 divided by 17. I'm not having very much luck. So there might be, I can't think of it off the top of my head. If you can think of it, please let me know in our live session. But I'm going to say that the square root of 97 can't be simplified. It doesn't have any perfect square factors. So our final answer would be -5 and then plus or minus the square root of 97 over 6. And then, by the way, I know you guys can't see it, but when I am like guessing and checking on my factor tree, and this is what you should be doing too, is I'm just using a calculator like off to the side. So if I say like 97 divided by 3 as a decimal, I just plugged it in and got it that way. So I would do the same thing if I were you. Okay, and then the last one is to find the zeros of f of x equals 4x squared minus 12x plus 9. So finding the zeros means that we have to take like f of x and just replace it with 0, because we're just looking for the x values that make the function equal 0, which doing this will help us find those. So we're going to go through and figure out what each of our a, b, and c are. So a is 4. B is -12, C is 9. So I'm going to put my A equals 4 right here and right here. And then my B is -12. That'll go right here and right here. So I'll kind of have a funky double negative to deal with. And then my C is 9. So that'll go right here. So we'll just work on putting everything in their correct place. So I'm going to create my fraction and just fill in from there. So I have -b first, but b is -12, so it's going to be -12, and that double negative will turn to a positive. If you just wanted to change it right away, you could. And then inside the radical, b squared, which is -12 squared, and then -4 times a, so times 4, times c, so times 9. And then over 2a, so 2 times 4. And then create your fraction again, just kind of fill in from left to right. So -12, double negative turns into a positive, so it's +12. And then plus or minus the square root of, let's see, -12 squared is -12 times -12, so that would be a positive 144. And then next I have -4 times +4, so that's -16. And then times 9. So I would do -16 times 9, which is 144. So it's going to, or minus 144. And then I have over 2 times 4, so over 8. I misspoke, I didn't misspeak, but I kind of stuttered a little bit on that last part. So inside the radical, one more time, I had -4 times -4, that's -4 times 4 is -16. And then -16 times 9 is -144. So it was -144. So kind of like a tongue twister. Okay, so moving on to the next step, now I can subtract inside the radical. So I have 144 minus 144. So that is 0. So I have 12 plus or minus the square root of 0 over 8. And then the square root of 0 is 0. So from this point, if you have like plus 0 and minus 0, they're both going to be 12. So it doesn't actually change anything. And you just go ahead and take off that square root of 0 or the 0 altogether. So it'll be just 12 over 8. And then from there, we just want to reduce to get our final answer. So to reduce, we would divide by a common factor, which the greatest common factor of 12 and 8 is 4. So I would do 12 divided by 4, which is 3, over 8 divided by 4, which is 2. And then I have my final answer of 3 halves. So it's just x equals 3 halves. And you'll notice like this answer definitely looks pretty different than our last answer. And honestly, because our answer is so simple, it's just because this problem could have been solved, or we could have found the zeros by factoring technically. So just kind of full circle shows you that like you can use the quadratic formula to solve any problem. However, there are not usually, but for some problems there is a more efficient way. So we'll talk in class about like kind of figuring out what's more efficient for which problem. But just know you can technically use the quadratic formula to solve any problem.